Last week, we were concerned mostly with depth of field and various ways to do it, both in a normal optical way and enhancing things digitally. This week, we're going to start a couple of weeks on dealing with motion, on rendering motion for still photography. And it's an interesting problem because we're dealing with a non-moving image. We're not dealing with video or motion film or anything like that. We're dealing with a final image that has no inherent movement in it. But suppose our subject is moving. How are you going to indicate that it's moving? Well, here's a first hint for you. We learned how to do this from the comics. Any ideas? Is that ringing a bell with you? Let me give you another hint. It's Superman up in the sky. It's a bird, it's a plane. In this case, it's a dog and a flying man. But how do they indicate that he's moving and moving forward? They do it with a drawn-in streak. Or it's also done with a blur. And what's important is there's a language that we've developed for this. That blur is behind the object that's moving. They're going in the direction opposite of the blur. If this blur were in front of him, we would automatically assume that he's backing up. So we not only use a blur, we use it to indicate motion. It tells us a lot about what's going to happen. The longer the blur, generally, the faster our subject is moving. Well, why do you need to worry about this? What ultimately is the point of all of this? Well, the point is, last week we explored depth of field used as a compositional tool, as a means of helping to tell your image's story. This time, we're going to look at images where the core of them, the basic movement, the basic arc of that story is tied specifically to its motion. So we need to find some way to render that in a photograph. What we're interested in, actually for a photographer, is motion relative to the image area. Not just any motion, but relative to the image area. And let's see what we're really talking about. Here, this white rectangle represents and is proportional to the image area for a DSLR, or for that matter, to 35 millimeter film. What we're really talking about is any kind of movement, any motion that's taking place across or around that image area. That's what we've got to work with, and that's what we've got to figure out. How are we going to render that? So first, let's figure out why that motion may be there. What can cause it on the image plane? Remember, it's relative to the image area. So that means it could be resulting from several things. One is the camera could be still on a tripod or braced up against something, and the subject is in motion going by it. Or perhaps the subject is still and the camera is in motion. Sometimes both the camera and the subject are in motion. And sometimes there's motion, the subject is moving, but in order to tell our story, we want to freeze that motion. All of those are possible for us. So let's take a look at some of those. First, let's look at items where the camera is still, but the subject is moving. All of these photographs, by the way, came from students in previous 143 classes. This is the most common situation, particularly for people at sporting or other kinds of events. So here we have a dance, long shutter speed, the camera is planted, and you get a sense that the dancers are moving around the floor, that there is some activity going on here. Here's a shot of a flagpole in a heavy wind with the camera planted, but it's really whipping around, creating all of that blur for it. Here are the little train cars out at Balboa Park. They're whipping around the area. The problem with this is that frequently it definitely shows there's motion, but it doesn't always tell us what is in motion. We can sort of figure it out here from these cars and the place, but it's not a really satisfactory shot. So generally speaking, this planted camera with a moving subject is not the best way to show motion in a subject. But what if the subject is still, but the camera is moving? Well, this is the kind of thing you see when people take shots out of the window of a moving vehicle. A lot of times they'll be in some pretty countryside and just can't resist it, and they'll hold a camera out the window and shoot the scenery going by. And frequently they get the leading edge of it totally blurred out. It's also not a particularly satisfactory way to deal with motion. Normally, there are exceptions to all of these, but normally, no, it's not really the ideal. Generally, to really render motion, what you'll end up doing is panning, moving the camera with the action, keeping the camera steady relative to the action. So here, the camera is panning with this motorcyclist. They're doing this in such a way that the motorcyclist is pretty much steady on the image plane, even though he's moving. As far as the camera knows, he's not moving. What is moving is the background as the camera sweeps by at a different rate than the motorcyclist. So we get this sense of blur that tells you, no, he's really moving. Here's a really good shot of it and a way to indicate that. And here's another one. Here are a couple of skaters going down the sidewalk. That blur in the background with them steady indicates that they're probably moving right along on those skates. And here we have a runner. The blurred background and the leg blur, because it's motion in a different direction, all indicates that he's running, that he's probably running fairly fast. And all of that story, that part of the story, is told in this blur, in this kind of action. Sometimes, using a slow shutter with the subject in motion, following it in motion, then you can create almost an impressionistic type of image. And here was one taken of one of our students' dog pulling her wheelchair, which he seemed to love to do. It's a really impressionistic shot, but it has a sense of the movement and the frenzy that he would grab it and just go blazing down the sidewalk with her in the chair behind him. Here was a shot using a zoom. What's actually moving is the zoom range on the camera with a long shutter speed. That's why you get this radial kind of blur. But there are times where the subject is in motion, but in order to tell your story, you want to freeze that motion. And here's a good example. This little girl has just thrown a bunch of leaves in the air. She's having a great time playing with all the leaves in this park. Nobody assumes that the leaves are just hanging there, floating forever. They're obviously falling. But by freezing it, we really get a sense of what's happened, the expression on her face, the leaves all in the air. We've told a pretty complete story with this image. Here's one with a surfer. Obviously, he's really moving through the water. You can see the splash. You can see his form on the board. This kind of thing is done frequently doing sports analysis for different kinds of activities to see what's your form like, how are you doing it. But it also really gives a sense of movement. But it depends on us looking at a scene in which we know inherently that the stuff in the picture is actually moving. Here's a skateboarder in the air. Well, most people can't levitate, so there's a pretty good assumption that he's in motion up in the air doing this. But if he were just on his skateboard, he could be rolling by slowly, or he could just be standing there. There would be nothing in that shot to indicate that he was really moving. Here, with him in the air, we know he's moving. So what is the correct shutter speed? How are you going to determine where to set your shutter in order to get the shot you want? Well, the first one is a little tougher. It's your vision for how you want the motion to be rendered that ultimately controls everything. There's not much I can do to help you here because it's your vision, not mine. You may, in your mind's eye, when you see this activity, you may see it flowing and blurred. I may see it frozen. You may see it with everything jumbled and expressionistic, and I may see it in a very different way. This is something you, as the artist, have got to determine for yourself. What do you really want this to look like? So do your research. Do your testing before the critical shoot so you can see options on it. And go online. Search for other photographers' approaches. Find out what works. what really appeals to you for different types of subjects. And then when you go out to do your testing, you'll have a goal to shoot for to see what you can determine. That shutter speed ultimately is also based on the subject's velocity. And what velocity are we talking about? Well, we're talking about motion, remember this, relative to the image plane. So what we want to know is, how long does it take the object to cross the image plane? That's the speed we're really concerned with, not so much some objective miles per hour or kilometers per hour. We're really looking at how long does it take to cross the image plane. And what affects that velocity? Well, there are several things. One, of course, is the actual speed of the subject. How fast is it going in that miles per hour or kilometers per hour measurement? Well, can you estimate that accurately? Most people can't. Some highway patrolmen can, but mostly it's such a guess that it's almost worthless to try to do that. And even if you could, if you knew for sure it was going, let's say, at 20 miles an hour, can you judge the angular velocity and the velocity effects of that subject moving away from the camera or doing its motion farther from the camera? Most people cannot, but it's important. And here's why. Here's one of the effects of velocity relative to the image plane: the angle of the path across the image plane. So let's illustrate that. Here we have an illustration where these two blue lines coming out from the lens indicate the field of view of that particular lens, looking out into space. This little red line represents the distance traveled by a subject at a given speed, moving straight across the image area, perfectly parallel to the image plane. And for all of the illustrations we're about to do, we're talking about an object moving at the same actual speed, no matter what the direction or angle they're moving at. So here, something at this distance is going to take a certain period of time to cross the image area. But suppose that they're moving at an angle. Here, the green line, the extent of that green line, shows how far they have actually moved. But the little red line below shows how far across the image plane they have moved, which isn't very far. So their velocity is a whole lot less once they're moving at an angle to the camera. How much less? Depends on the angle. Are you really good with trigonometry? I'm not. So trying to tell you what the right shutter speed for that is would just be incredible guessing on my part. So that angle simply hasn't allowed it to cover much distance across the image area. How about the distance of this action from the image plane itself? What if it's going on further away? Well, let's illustrate why that's a factor. Here, this red line out away from the lens makes it clear that an object at that distance has to go farther and is going to take longer to cross the image plane than something that is closer to the image plane that isn't going to have to move as far. So effectively, that object at a distance is moving slower than the one that's closer to the image. Those have to be factored in attempting to find the right shutter speed. So are you confused enough already? Wow, this is a bunch. And ultimately what it boils down to is there's no way to really tell you what the right shutter speed is. So what do? How do you deal with it? Well, you can find online material that will give you some estimated speeds of some objects. And they'll also suggest shutter speeds that you're going to need to stop the movement based on a particular actual velocity, assuming you knew what that was. But the way to really do it, the way professionals do it, is to test for it. If they're going to be shooting a race, they'll be out the day before during time trials and practice it, determine what's going to be needed in terms of shutter speed to render the image as they want it. Then when they go out for the real shoot, they already know the answer to that, and they're not going to risk missing an important shot with the wrong shutter speed, with the wrong approach. So now, review this if you think it would help you to get a better sense of this. Read the assignment, grab your cameras, and go produce some stunning motion photographs for this week's material on rendering motion. Next week, we're going to talk about extreme motion. See you later.